Investigation 2.3. What we're looking at is we are basically looking at graphs and trying to distinguish patterns and trying to make a story out of those patterns. So in other words, you're looking at graphs that don't have any labels, and we're going to basically put labels on them. So questions A through G describe pairs of related variables for each pair. So the first thing that they want us to do is to decide which variable is a dependent variable and which one is an independent variable. The next thing that we're going to do is find a graph that tells a reasonable story about how the variables might be related. And last thing is explain what the graph tells about the relationship and give the graph a title. All right, what I'm actually concerned about that we're going to actually look at in class is the first bullet, decide which variable is a dependent variable and which is the independent variable, and then find the graph. Okay, those are the two main things that I want to get out of this lesson. All right, so those are the two things that we are going to focus on. So let's get started. And what we're going to do is I'm just going to make a general graph, and I'm going to use this every single time, okay, for each one. So that's A through G, okay, and I'm not going to do all of them, but I'm going to give you an idea. Well, actually, we'll do all of them. All right, so A, the number of students who go on a school trip is related to the price of the trip. You'll notice that they italicized certain words because those are our variables. All right, so the variables are number of students and price of the trip. Okay, so which variable determines which? From the looks of it, my price is determining the number of students. Okay, so let's see if that makes sense. The number of students who go on a school trip is related to the price of the trip for each student. So if the price is too high, then the number of students will be low. If the price is low, then the number of students will be high. That seems to make sense. Okay, so that's the one that we're going to go with for this. All right, number of students is your dependent variable, and price is your independent variable. All right, you're going to need to keep track of all these. So I made mine's big, but you're going to probably want on a separate piece of paper, label each of these separately, A, B, C, D, E, F, G. Okay, so you'll have a whole bunch of these graphs sitting on your sheet with the labels on it. All right. The next scenario. When a skateboard rider goes down one side of a half-pipe ramp and up the other side, her speed changes as time passes. All right, so this one should be easy. So time, no, I'm just going to do this in case so there's no confusion. This is for B. Time and speed. Because remember, time is generally speaking always on the x-axis, so therefore speed has to be on the y-axis. Okay. C. The water level changes over time. Again, not too bad. Time, water level. All right, so you can kind of see the process that I'm going through, where I'm just going through each of these, making a separate graph, labeling everything, and then we'll do the harder part where we try to match it up with the story. All right. D. The waiting time for a popular ride at an amusement park is related to the number of people in the park. Okay, so now this one we have to actually think about. Okay, so it seems as if it's saying the number of people in the park is going to determine how long you have to wait for a popular ride. Instead of saying the time that I have to wait will determine how many people are in the park. So the other way sounds a little bit better, because the time that I wait will determine the number of people in the park doesn't really make a whole lot of sense if you think of it that way. So, number of people in park is going to determine my waiting time. All right, so we got all that down. This isn't so bad after all. I thought this was going to be a little hard. Okay, that one was a little tricky, but not too bad. Okay, E. Number of hours of daylight changes over time. Number of hours of daylight. Okay, as the seasons change. Okay. Time, and I'm just going to say hours of daylight. All right, that takes care of E. F. Weekly attendance. So attendance at a popular movie changes as time passes from the date the movie first appears in theaters. Okay, so I had to kind of think about this one. All right, so what it's basically saying is the longer a movie is out in the theater determines how many people attend the movie. All right, so I think I get that. All right, so the wording of it was a little weird. So I think if I explain it like that, it might be a little bit easier to figure this out. I mean, granted, for the most part, you guys are saying, oh, you just put time on the x-axis. All right. But I want you to really understand what the question is saying. Yeah, I'm going to abbreviate attendance. So weekly attendance is determined by the time. I'm going to make a little note here. In theaters. Okay, so that takes care of F. Now the reason why I'm saying you need to focus on not just placing the variables, but kind of understanding what the scenario is saying, is because in the next part, we have to actually match up. So we have to actually look at what the graph is saying and try to see if it relates to the story. So you have to really kind of understand what it is that each of these is trying to say. All right, so G. Ooh. G. The number of customers at an amusement park with water slides is related to the predicted high temperature for the day. All right, so let's see what this is saying. All right, is it saying that the number of customers at a water slide determines the temperature for the day? Or is it saying the temperature for the day determines how many people show up at a water park slide? The second one makes a lot more sense. So, high temp and number of customers. Okay, so we have everything labeled. Okay, so all of our graphs are labeled with the X and Y axis. And again, it's going to make a lot more sense if you have these all written out, okay? Because the next thing that we have to do is look at these 6 graphs and go through each and every story, okay? So I'll give you an example of what I'm saying. If we look at A, the number of students who go on a school trip is related to the price of the, actually, okay. The number of students who go on a school trip is related to the price of the trip. So the price is determining the number of students. So what I'm actually doing is I'm picturing this. Price, number of students. You're not going to write this on your sheet. Price, number of students. This is what you kind of have to picture, though. I can do this because I can erase it. Oh, it's taking a long time. Okay, price, number of students. Okay. So, I have all these labeled. All right, now I have to try to picture the story. Okay, so graph 1. As the price increases, the number of students increases. That doesn't make any sense. So that's not going to work, because as the price increases, the number of students is going to go down. This one says the price right here, if you remember, is 0. So at 0, a whole bunch of students want to go. Then as the price increases, the number of students goes down. Well, heck, that could work. Okay, that could actually work out pretty good. So that could be A. Okay, graph 3. At 0, it's pretty high. As the price increases, the number of students can't increase. That doesn't make sense. Graph 4 is not going to work. At 0, no one wants to go. That's not going to happen. That is definitely not going to happen. All right, next graph. At 0, a whole bunch of people want to go. As the price increases, the number of students goes down. And then at some point, when the price is still going up, the number of students goes up. And that is not going to happen. All right. And at 0, no one wants to go. Not going to happen. All right, so the only graph that makes sense is graph number 2. Now, you have to go through each graph because there could be possibly more than one answer to these questions. And that's what we're going to look at in class. So what I want you to do is you're going to go from B through G, and you're going to do exactly what I just did, okay, trying to match all these up. And in the next video, I'm going to basically go through this whole scenario with each one, okay? All right, so good luck with this, and we'll talk about this more in class.